Welcome to Section 7, Akka Streams. In the previous section, we introduced you on how to test actors. In this section, we will introduce the new module in Akka, that is, Akka Streams. At the moment of recording, streams are in version 1.0 experimental, and slight API changes may still happen. However, it's stable enough to be used already, so let's take a look. Here we will take a quick look at Intro to Akka Stream and its terminologies. Then we will implement our stream application, Reactive Tweets, and test the Reactive Tweets application. We will then work with graphs and with Stream I/O. Let's start our trip in the stream world. In the first video, we will take a look at the problems of fast data and streaming processing world and why we should be using Akka Streams. Next, we will introduce the basic terminology in Akka Streams and implement our first stream app. Let's start then. Big data has been around for quite a while, and it's usually batch processing. In the current world though, we're starting to talk about fast data, which means we want to process the data right away when it hits our servers, for example. Akka Streams are a library, which allows implementing either style of application and guarantees that it will execute on bounded buffer sizes, will not cause out-of-memory errors. The two main problems streaming data solutions need to tackle are blocking and back pressure to survive high-load scenarios. Blocking can happen in a pull-based system. This means a consumer pulls data from the producer. Blocking takes place when there is no data to pull. This is safe for the consumer. It will not run out of memory. However, it is also very slow to build systems based purely on pulling data. The other problem is back pressuring too fast. Producers of data when working with pushing data. In pull systems, it's not as visibly needed. However, they are slow, and we want our systems to be fast. The need for back pressure arises when the producer wants to create more data than the consumer can handle, which can cause the consumer to crash. Let's take a real-life example to understand these problems. Let's imagine we have a source of water and a sink, which we want to fill, and we have pipes between them. If we decided to put a pump at the end of the pipes to pull the water, the pump will still work, even if there is no water on the source. And if we move the pump to start off the pipes to push the water, the pump will still work, even if the sink is filled and the water just overflows. To fix our problems, we need to put a pump on the source and cap on the sink. This means the pump will work when a source contains water. And when the sink fills, the cap will create back pressure and trigger the pump to stop pumping. This is exactly what Akka Streams do when it comes to solve the main problems on streaming data processing. Akka Streams describe the solution as asynchronous dynamic push-pull back pressure. Now, let's discuss the main parts of Akka Streams. The main elements of Akka Streams are source and sink. The source is where data begins to flow from. It has the output port and no input port. The source in our example may be a river. In applications, it may be a query from the database or HTTP request bytes. The sink is the end of the stream. It has the input port and no output port. In our example, we were directing the flowing water that we have collected in a sink. In real-world applications, it may be the stored data in the database or data written on a file, so we'd have a file sink. As streams can have multiple processing stages between a source and a sink, we also need to name this concept. In Akka, it's called a flow, and one can flow the data via a flow, from source via flow, and finally to a sink. If you want to make things more interesting on the stream, you need to add a flow between the source and sink. A flow can be used to apply transformations to the data coming out of a source before putting it into a sink. When connecting the source to the sink, we get a runnable flow. A runnable flow is something we can start. In other words, it's a flow with a sink and a source attached, a complete stream pipeline. This is the most basic complete form you can make in Akka Streams. This means you must connect your source with a sink to have a complete system, and your data can flow through it. Now, let's implement all this into a simple app. Akka Streams provides this nice type-safe DSL to build streams from. The actual execution of it is actually handled by actors underneath. Here's how we can build and run a simple stream. We will talk about them in the next video. First, let's define our source. Let's say we will generate iterators from 1 to 100. Next, let's define a flow. Let's say we want to multiply it by 2. Then, let's create our sink. In our sink, we will print the elements. Now let's run our app. Voila! Our Stream app is working. This is a simple application, but we have used all the basic elements on it. See you in the next video, where we'll implement another Stream application, Reactive Tweets.